today we're solving logarithmic equations and exponential functions. So you definitely need a calculator if you didn't grab one. Oh, I didn't mean to move my desk.
I got you.
Also, did anyone leave a sweatshirt here?
No.
I found one on the floor.
Jerry, you didn't send it.
That's fine. Shit! Amanda, go back to your desk. Okay, so when I have two exponential pieces, what I want to do is I want to rewrite them so they have the same base. What would be the same base for 100 and 1 over 10? 10. So how do I rewrite 100 to be a base of 10? 10 squared? Okay, what about 1 over 10? 10 squared is 100, Jerry. Because I want them to both have 10 as a base. The x was there to begin with. Okay. Kind of. Why are you so mean, Jerry?
Why are you so mean?
You're being mean to her. Okay, how do I rewrite 1 over 10 as a base of 10? What exponents does that need to have? Yeah, because I want them to have the same... Yeah, but I need it to be a regular 10, not a fraction 10. So what exponent do I need to have? Nope, fractions are what kind of exponents? We talked about this the beginning of the semester. Guys, you have to be quiet. Kind of. Negative exponents. Mm-hmm. Okay? Who was, I know who it was. Why was he so rude?
So you flip the fraction and change it to
He only wrote something mean about fifth hour. So then I want to multiply my exponents. He didn't say anything bad about you guys, just... Whatever. Apparently fifth hour half the class wasn't working at all and they had immature comments. Yeah, because I distributed the negative. Any other questions so far? I'm sorry. So now that they have the same base, what I can do is I can set the two exponents equal to each other. So I'm just going to have 2x equals negative x plus 3. The 10s don't even matter anymore. So that's why I was trying to get them to have the same base. Okay. And then I solved this like a normal algebra problem. So Enid said to add x to both sides. Yeah. 3 divided by 3 is 1. Questions here. Yeah.
So the base would be the 9.
The base has to be the same so I can set the exponents equal, but other than that, it doesn't matter what the base is.
So after that, after you figure out your bases, the base will be 9.
Okay, so on number 2, notice this one, there's no way I can rewrite 7 to have a base of 2, right? Literally no. So the way I solve this is, remember, I told you logarithms are the inverses of exponential equations. So I'm going to do log base 2 of 7 equals x. So now what can I do with this? Well, first of all, where did the 7 and x, where did those... Yep. The 7 went here, and the x went here at the end. Yeah, that was why we learned how to rewrite, so we could, when we got to this point, learn how to solve. So then, how would I solve this? Yep, I put it in the calculator. Do you remember where to go? 2.81? So to get here on the calculator, you go to math, and then you go down to log base, and our log base is 2. Yeah. Yeah. And then we rounded. So 2 decimal places. Questions on number 2? Okay, so any ideas on how to solve number 3? That's what it means, but notice number 3 is very similar to number 1 in the fact that they're both ln's on both sides of the equation. Yeah, so what I do is I actually just ignore the ln's, and then I set the two things inside the parentheses equal to each other. Yep. Okay. So, how do I solve this one now? Minus what? Yeah. So I get 3x minus 7 equals 5. Then what's the next step, Amanda?
I don't know. Keep it up. Keep it up.
Yep, I can pick these up. Okay, what's my next step? Divide by 3. So my answer is not on these ones. Curium. Okay, so number 4. How do you think I rewrite this one to solve it? No. So this is the opposite of number 2. So what I'm going to do is I'm going to have my base is 2, my exponent is 3, and then it equals 5x minus 17. Nope, because I write the inverse of it, which is an exponential function. Yep. So Jerry told me it's 8. What? Oh, you said add 17 to both sides, Jerry? Okay, then what? X equals... Questions here. That's off the screen. I'm sorry. So questions on solving logarithms. Okay, I have one more example to work through. So notice this one I have 2 logarithms and then equals a number. The way I want to solve this first is I want to condense it. So remember what we were doing, what did I say? No. When I condense them, I multiply the insides together. So then it's going to be log and then 2x times x minus 5. And it still equals 2, even though I wrote down 5. I multiply, Jerry. So 2x times x is... And then 2x times negative 5 is... negative 10x equals 2. So then... I want to rewrite this. When I don't have a tiny number, what do I do? Okay.
1.
No. Log is always in base 10. Yeah. Oh, it does. My bad. It's just 10x. So then it turns into 10 squared equals, because this is a different 10. This 10 came from the log not having a base. Yeah. Yeah. Then I solve it like number 4. Girls, be quiet. So 10 squared is... Okay, what do I want to do next? Nope. So whenever I have a quadratic equation, I always want to solve it.
Set it equal to 0.
Yep, I want to start by setting it equal to 0. So I'm going to subtract 100 from both sides just because it's easier to move one number than two. And I get 0 equals 2x squared minus 10x minus 100. Yeah. How would you like me to move it? This way? This way? Right here and then up? There you go. Manny said to divide by 2. Does everyone see why he wants to do that? Because I have a coefficient out front, and it's easier to deal with if there isn't one. So, that's a 2. Yeah. What multiplies to... Dang it. 100 divided by 2 is not 20. It's 50, right? Okay. This one on the screen. There we go. Because that's what I divided by. You can't just completely disappear. Okay. So Enid says negative 10 and positive 5, right? Okay. Am I done? That's what we divided out. No, this one?
Yeah.
The 2? No. It's just a 2. We don't worry about it. Because we know 0 doesn't equal 2. So. Yeah, I equaled the 2 parentheses to 0. Okay, so on this one, this is the one where I need to check my answer because anytime I make a squared, I have to check because sometimes they don't work. Yep. Yeah, so I'm going to plug in. I'm going to plug in the negative 5 first. So if I type in the whole left side into the calculator gives me
So you just plug that in the log 2.
just the left side. Okay. So what does the calculator give me? Oh, because I typed a mistake. So I typed a mistake. Yeah, it's still minus. I just wrote it wrong. It should be 2 because that's what I have on the right side. So when I type it in the calculator, I'm looking for 2. Yeah. This one might need double parentheses. Well, it needs, because it starts off with parentheses when you hit the log button. So you need to double and close it. Yes, exactly. It says error. So, if it's saying error, is that going to equal 2? No, so this one is not a solution. If you plug in the 10, it'll work. I just wanted you guys to plug it because I was running out of room. So it says error, non-real answer. That means negative 5 is not a solution, but if I go back and I plug in 10, it should work. We're almost done. I write that because that's part of the equation. No. I only typed in the left side. No. You only circle your answer, so it's just that. Okay, so questions here? No?